Good morning, students. Today's topic is transmission line. That is transmission of electrical power from one place to the another. So how it is transmitted, what are the parameters involved through which it gets transmitted, what are the phenomena occurring, all these things we'll see. That is transmission of electrical power from one place to another. So we say from one place to another, so let it be like more electrical way. We say transmission of electrical power from sending end to the receiving end. So when something is sent from one end to the another, so we know that electric power will be transmitted through a transmission line. So while passing it through the transmission line, there are chances of occurrence of losses. So we will see what are the losses happening. So how much power we will get at the receiving end from the source, from the source end to the receiving end, what are happening. So in our previous classes, we have understood what is the source. What is the source and how the electrical energy is generated in those sources. All these things we have covered. And then after that, we also studied about some parameters like capacitance, inductance, what is happening, how it is happening, all these things. And then finally, we are at transmission lines, which is connecting all those things. Okay, fine. So as an introductory part, I would like to say that the electrical power generated in the generating station, so many generating stations we studied, so let it be any of them. So the electrical power generated in the generating station is transmitted with the help of transmission lines. Okay, transmission line is a conductor or conductors. It can be more than one conductor designed to carry electricity or an electrical signal over large distance. So electricity can be transmitted in a small distance, medium distance, and large distance also. So keep my point there. So based on that, there is a classification: long, medium, short. Okay. So with minimum losses and distortion. Okay. Sorry. The parameters associated with these transmission lines are inductance, capacitance, resistance, and conductance. I already told you from the first slide. So while electricity is being transmitted, there are many parameters that is coming in effect. These include inductance, capacitance, resistance, and conductance. From the source end to receiving end, when electricity is being transmitted, these all things come into effect. These parameters are uniformly distributed along the length of the transmission line. You see, along the length of the transmission line, they are uniformly distributed. For good electric design of a transmission line, a sound knowledge of all these parameters is essential. So what is the key point? Now what all are things? Because electrical energy is being transmitted from source to receiving end. So source can be any generating station which you studied. While being transmitted, there are different parameters that come into effect. So electrical power is going through these parameters, which are the resistance, inductance, capacitance, and conductance. Okay. Then we will see the factors to be considered while deciding the transmission line, like which type of transmission line we need, like whether we need a long one or we need a short one, or we need ACSR type, or different types. You will be like, well, whether we need overhead or we need underground transmission lines. All these things we need. So the factors which are affecting is type and size of the conductor, efficiency of transmission line, corona loss, not the corona we have now. This is corona and electrical. For an electrical engineer, corona is something different. Okay. Power flow capability and stability, then the economical aspects. Okay, these points. So these are the points to be considered while selecting the transmission line. Okay, now we will see the classification, different classification of the transmission lines. We have the overhead transmission lines, which we have outside. Maybe when you get out from your house, you can see that overhead transmission lines. It can be short transmission, medium transmission, and as well as long transmission. Okay, then we have underground cables. Underground cables are usually set up in areas where we don't have the provision for overhead transmission lines, because we prefer overhead transmission lines, because in case of underground doing maintenance and all, it's very difficult. Normally, we will have manholes and also people should go inside. Before going inside the manhole, we should do the gas test and all. So it's a very lengthy process and the risk factor is also minimal. It's very high. So mostly we prefer overhead transmission. If it is not possible for an overhead transmission line, we go for an underground. And underground transmission lines means it is very, it has some advantage also because it takes very less space also. It will be neatly inside the underground, so it will be inside. Such things are also there. Okay, so underground cables are there. So now we will see the overhead transmission line, different types. So I told you there is short, there is medium, and there is long. So short transmission line means the line voltage is less than 20 kilovolt. Remember 20 kilovolt, and length is up to about 50 kilometer. So you need to study only the basic about transmission line. So what is transmission line? What is happening? What are the parameters? Then different types. How we select a transmission line? So from a different type means we have the short one. Short transmission lines means less than 20 kilowatt, and the distance is 50 kilometer. Here in a short transmission line, the capacitance effect is very negligible. So capacitance, so just understand it is negligible. Why it is negligible and all, you don't bother. I will give you such information in the upcoming classes. Okay. Then see, we are so efficient. How we calculate the efficiency? I told you there is a source and there is a receiving end. So how much of it is coming to the receiving end from the source will give you the efficiency. So power received at the receiving end divided by power delivered from the sending end, sending or the source. So how? Because in total what it will be? We should consider the losses also. See here, this losses also. This is the loss happening when the current is being passed from the sending end to the receiving end. Okay, I square R losses, that also we should consider. Okay, as we normally say, no, output by output plus losses give you efficiency. That's that concept only. Now we have the medium transmission line. So I told you, there is a sending end, there is a receiving end. So this is the sending end or source, we say. So you go with the name sending end because in most of the textbook it is sending end only. So Vs is the sending end and Vr is the receiving end, and electrical power is being, Is is the sending end current. So electrical power is being transmitted, and I told you like there are parameters like resistance, inductance, capacitance and all coming in between. So current is being transmitted through that. So because of the involvement of R and L component, this phasor will come similar to the one we saw in case of power factor improvement. Now you need not go in detail to this. We will see it later. No problem. So just understand that for medium transmission line, the line voltage is moderately high. So it is greater than 20 kilowatt but less than 100. So the benchmark is 0 to 20 for a short one, then 20 to 100, 20 kilowatt to 100 kilowatt for the medium one, and distance is here 50 kilometer to 150 kilometer. 0 to 50 it was the short one, then medium is 50 to 150. And capacitance is significant here. We cannot neglect the capacity effect. Okay. Now we are going to the long transmission line, which is greater than 100 kilometer, and length of an overhead line is more than 150 kilometer. Okay. So here line constants are considered uniformly distributed over the whole length. So line constant in the sense the RLC parameters only they are saying here. You just understand like it is the RLC parameters. So we have it uniformly distributed here. See, this is uniformly distributed. Shunt capacitance is there. Shunt means parallelly connected capacitance is there. Such things only you need to understand. Different types. Now we will see how the conductors used to design overhead. What are the conductors used to design the overhead transmission line? So you have seen conductors passing through when you go outside or when you visit a substation or anything, you might have seen many conductors. The first one is ACSR, which is aluminum conductor with steel reinforcement, and ACAR is aluminum conductor with alloy reinforcement. Okay, ACSR is mostly used because used steel reinforcement, it will actually help us in increasing the tensile strength. That is aluminum conductor with steel reinforcement, and ACAR is aluminum conductor with alloy reinforcement. So the properties of alloy and steel will come into effect, and that in turn will help us. Then hard drawn copper conductor, then steel cored copper conductor, then phosphor bronze conductors, galvanized steel conductors, and AA is all aluminum conductors. So the properties of aluminum and steel, everything will be the conductivity property, everything will come into effect. That's it. That's the parameters that we use when to consider this overhead transmission line. Okay, so this is one rough figure of a ACSR cable, which is most widely used. That is aluminum aluminum conductor steel reinforced. That is ACSR. So steel, you see, steel will be there, and it is actually giving the support. And this is the conducting element, that is aluminum. Okay, you might you might have seen if you have visited a substation, or like if you have been to a place where electrical work is going on. If you might have seen, or maybe in any exhibition, or you have seen. The first time when I saw this was in my first year of BTech, when my college organized an exhibition. So they brought these things from KCB, Kerala State Electricity Board, and I could see this. Actually, that was the first time I think I came to know about this. First time, when in my first year BTech. Yeah. So this is the figure. Okay, so far we see what is a transmission line, what is happening there, what are the parameters that we went through, and what are the factors that we should consider while selecting a transmission line. Then the different types of transmission line, overhead and underground. So why overhead, why underground? Uh, uh, Briefly, I have explained to you. Then different types of overhead transmission lines, all such things, and then some types of cable and ACSR with the figure and all. And now we will be in the next session we will be handling why we need to whether we need to effect of transformer in the transmission of electrical power. We will see, like whether we need to step up or step down during transmission. That we will see in the next class. Okay, thank you.